Hello there guys, and welcome back to another epic Inexorable video. In this video we're looking at stretching graphs, okay? So this is again another video about linear transformations. This time we're looking at stretching these graphs, okay? Not translating them, moving them left, right, up and down, stretching them in either direction, or squeezing them, okay? Squeezing, what is that? There is a spider. Hello there, sir. Au revoir. Unless you would like to get involved in some epic linear transformations. Okay, anyways guys, sorry, we got disturbed. We want to stretch or squeeze graphs. Those two things are related to each other, okay? So basically a squeeze is like a stretch, but it's like less than a squeeze, if that makes any sense. So let's have a look at some notes, and by the way, I'll explain all that in a second. The graph y equals a f of x is a vertical stretch of the graph y equals f of x by some scale factor a, okay? So the graph of, for example, y equals 5f of x stretches the graph y equals f of x vertically by a scale factor of 5, okay? And so on. Additionally, the graph y equals f of ax is a horizontal stretch of the graph y equals f of x, but this time it's by a scale factor of 1 over a. Okay, so this could be confusing. Essentially, if a is large, if a is greater than 1, so let's say a was 5 again, f of 5x is actually stretching the graph by a scale factor of a fifth, which means we are squeezing the graph, okay? If a is smaller than 1, we are indeed stretching. Actually, in most cases, most of the numbers are bigger than 1, we're going to be looking at squeezing, okay, horizontally. Okay, so again, it's another case of like, if we have some stuff inside these brackets of the f of x, then funny things happen, okay? Like we sort of go backwards. It's like the unintuitive version. So what I'm going to do in this video, guys, is we're going to be sketching the graphs, the normal graph f of x, and also the translated, or the stretched, transformed version, I should say, on the same axes with different colors so we can see what happens, okay? I think that's probably a better way to go about it. So, here are our coordinates. Again, I don't know what the lighting is doing, it's sort of a bit annoying, but if you can't see what this says, it says f of x equals x squared, sketch y equals 2f of x, okay? So let's just sketch y equals x squared, okay? Again, we should know how to do this. This is just a sort of U shape, goes straight through the origin, comes up, okay? This is the graph, y equals f of x. Y equals x squared. Same thing in this case. We want to sketch 2f of x, okay? So looking at this, the graph of y equals, in this case, 2f of x is a vertical stretch of the graph y equals f of x by a scale factor of 2. So basically, we're going to make it stretched like this by a scale factor of 2. So in this case, you can't actually put any coordinates on the axes to show it, but I'm just going to sort of make this thing a bit taller. So it would actually look a bit more like, if that has to go through the origin, if I can get that. Like this, okay? So this would be y equals 2 f of x, okay? Just like that. As you can see, it's clearly just been stretched upwards, okay? It looks like it's been squashed like this, but it hasn't. It's been pulled upwards, okay? So that's essentially what's going on. Okay then guys, so we've got another question here. This is f of x equals x cubed, sketch y equals f of a half x, okay? So now our scale factor is inside the f of x. So again, we're going to refer to the notes. Essentially, we've got something that's in a transformation that's in the form this, y equals f of ax. We can identify that a is 1/2, can't we? And this is a stretch of the graph y equals f of x by a scale factor of 1 over a. So 1 over a half. So don't be confused. 1 divided by a half. 1 divided by 0.5, that's actually the number 2, okay? If you do 1 divided by half, you will get 2. Okay, so essentially this is a horizontal stretch, and it is a stretch of a scale factor of 2, okay? It's actually going to stretch by 2, even though there's a half in there, okay? So again, we're gonna do our coordinate axes like so. Here's the x-axis, here is the y-axis, here is 0. I'm going to sketch in black pen the graph y equals x cubed. It looks something like this. Haven't drawn it particularly well. Maybe this bit down here is a bit too steep. Something like that, okay? That's the graph y equals x cubed. So I'm going to say y equals f of x. Okay, now in purple pen, we're going to go and sketch y equals a half x, okay? And that is going to look roughly like that, okay? Again, not perfect, I know. This is the graph y equals f of a half x, okay? As you can see, it has indeed been stretched out by a scale factor of 2, roughly. Now, it's of course difficult to actually plot. I mean, the origin in any linear transformation, well, in any transformation that isn't a translation, typically stays as it is. So this also goes to the point 0, 0. Sometimes questions will ask you to state the intersections of the graph that has been transformed. And all you need to do is simply, well, typically you can say, well, y equals a half x is basically a half x cubed, like this. And so that is equal to basically an 1/8 x cubed, okay? So if you want to essentially figure out what the coordinates of maybe some intersections are, you would use your normal methods, okay? So you could say y equals an 1/8 x cubed, and then if you want to find what the y-intercept is, you'd say 0 equals an 1/8 x cubed, and you just rearrange that, and you would find that x equals 0. That hasn't changed. But sometimes it depends what the graph is, okay? Sometimes it will change. Luckily here, this point here is 0, 0, and it's also 0, 0 for both of them. That's the intersection, okay? They will ask you wacky questions, but that's essentially the gist of sketching, or stretching, sorry, rather, graphs. This is really what you need to know. It's these notes here. It's making sure that we're really paying attention to the fact that y equals f of ax is actually more like a squeeze than a stretch. It's called a stretch, but really it is a squeeze most of the time, unless a is less than 1. And that's essentially all you need to know, guys. Again, if you'd like me to sort of elaborate a bit more on this topic, please let me know. I'd be happy to do so, and I'll make more videos on it. If not, we can move on. Thank you guys so much for watching. Highly appreciate it. I'll see you guys in the next video. Cheers.